Welcome back, fellow programmers. And this is part two of our theory on neural networks. We last seen a network with an output of a true value in part one. While we also learn that we cannot use rules or protocol as an initial input to the neural network to get the truth or wanted results as an output. And we also learned that we have to actually train the neural network to get the actual truth results or the wanted results from the neural network. So we do this using back propagation. In back propagation, the first step is finding the error rate. So here we have the error rate of the four outputs: solid, vertical, diagonal, and horizontal. We add up the error rate to get the errors to get one total error rate. We have the truth, which is the wanted output, okay? And we have the answer, which is the actual unlearned output of the neural network, or untrained answer from the untrained neural network. So the error between the truth and the answer, so let's say the error is the magnitude between the truth and the answer. We take the magnitude and we get the error. We add them all up. Here it is 3.25. Now that is somewhat of a high error rate. We need to deduce that down the best that we can to 0.01 error rate, which is also to say 99.99 accuracy. So we do that by adjusting the weights in the neural network. So we can adjust this weight up or down, whichever way that deduces the error rate, and we call this gradient descent. We want to deduce the error rate by adding or subtracting the weight. So here we have added ever so slightly, just 1 to the weight, and that created a change in the error to give us a -2. And so the change in weight in relation to the change in error, this relation is the actual slope. So we can say that the slope is equal to the change in error in relation to the change in weight. And we can also say the slope is equal to the derivative of E with respect to W. In this case, we added 1 to the weight, which made the error -2, which gave us a slope value of -2. So here we have a regular or simple neural network with an input layer, a hidden layer, and an output layer with a weight in between each layer. We can say that y is equal to x times the weight. If we change the weight ever so slightly, then we'll get the derivative of y with respect to the weight equals the slope, which is x. So I'm not going to give a calculus lesson here, but what I want to point out is that the derivative of E with respect to the weight is equal to the product of the first two derivatives. Okay? And with that, we will take and multiply every derivative for every little change. And we will multiply them to get the overall slope in the chain. And this is called chaining. So we chain the derivatives or the slope, and we feed it back, or we back feed it into the neural network. And all of the calculations, the weights, the synapses learn from our input that we put in the output and ran it backwards to back propagate to teach the network. So it learns, goes through the synapses, comes out the input layer, and then goes back into the input layer. And it repeats this step with the proper calculations and adjusting the synapses and the weights according to our corrected input until it comes out with a truth value or a value that we want from training it. And once it learns that value the way we want it to be, then it will output it according to whatever error setting that you set it to, the best being 0.01 or 99.99% accurate. So this will conclude part 2 of our theory on neural networks. Next, we will jump into some coding and implement a neural network.